These are your chemistry notes. This is going to be section 1, which is on atoms, elements, and compounds. I'll be teaching you via this presentation, and then we will be doing some different stuff in class. You can pause me at any time to take more notes, add to them, make drawings, do whatever you need to do. Section 1 is all about matter. Matter, if you recall, by definition, is anything that takes up space and has mass. It is composed of tiny particles called atoms. All biotic and abiotic factors are composed of matter. Thus, everything has matter in it. Atoms are the building blocks of matter. So, what does matter make? In the next part, we will learn about the 3 particles. The 3 particles of an atom are protons in red, neutrons in blue, electrons in gray. A proton is positively charged and can be found in the nucleus. They are always written as little p with a little positive sign to indicate that it is positively charged. Neutrons are neutrally charged. They are also found in the nucleus, and they are written as N with a little 0 to indicate that they are neutrally charged. Electrons, you can see, are gray, and they are not in the nucleus. They are in what we call the energy cloud or in energy levels. Again, they are negatively charged. That's why we write them as little e with a little negative sign. As you can see by the diagram of helium, it has 2 electrons floating in the energy cloud or energy level, and it also has 2 protons and 2 neutrons in the nucleus. Electrons are always constantly moving in their different energy levels. This is really important when we talk about bonding. Therefore, all protons will always equal all electrons. So, if an atom had 10 protons, it should have, you guessed it, 10 electrons. The next biggest thing is what we call an element. An element is a pure substance that cannot be broken down by physical or chemical means. What they're saying is that it is in its simplest form. It can't get any smaller. The periodic table is a chart that many people use to find and use it to find useful information about elements. It is set up in columns, rows, and groupings. For us and our class, we're only going to talk about horizontal rows and vertical columns. Horizontal rows are what we call periods. Vertical columns are what we call groups. Each element is also represented by a symbol, usually some kind of letter. The first letter will always be capital, and the second is always lowercase, if there is a second letter. For example, H stands for hydrogen, O stands for oxygen, Cl stands for chlorine, and A, that's kind of a tricky one, but that's actually for sodium. They use the Latin form of sodium. Li is lithium, and Fe is another tricky one, that's iron. They're also using their Latin form. So let's practice a little bit more with our elements on our periodic table. If you notice where hydrogen, lithium, sodium, potassium, rubidium, cesium, and franconium are, they're all in a vertical column, and we call that, again, a group. That's called a group 1. That means they only have 1 electron in their outer shell. So then group 2 would have 2, and so on and so forth as you go across. Same thing with rows. Hydrogen and helium have 1. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they all have 2. So on and so forth down, and that's representative of how many energy levels each one has. That is when an element has a different number of neutrons than normal. The best one we always talk about is carbon. Carbon should have 6 neutrons to make it a normal carbon. However, if it becomes an isotope, that means more neutrons are there than normal. So if we say carbon 13, that means that it has 7. Or if we talk about carbon 14, it now has 8 neutrons instead of the original 6. We use this when we talk about radiometric dating or isometric dating. Now we're moving on to something even bigger. That's called a compound. A compound is a pure substance when 2 or more different elements combine together. For example, you see the water molecule. It has 2 hydrogen atoms, which are red, and 1 blue oxygen. That makes H2O, or water. Another example would be salt, NaCl, sodium and chlorine. How about carbon dioxide? We've talked about that already. Carbon dioxide is CO2, so that means that there is 1 carbon and 2 oxygens. When a compound is made, it is in a specific ratio, just like I said, H2O for water, CO2 for carbon dioxide. It cannot be broken down by any kind of physical meaning you can't rip it, you can't tear it, you can't crunch it up. It's always going to be water. There are 2 main types of bonding. One is covalent and one is ionic. I'm going to discuss covalent bonding first. Covalent bonding is when electrons are shared, and the goal is to make sure that that outer energy level is full. And again, we're going to use water as our example. If you notice the oxygen, it has 6 on its outer level, but it needs 2. Well, hydrogen has 1, and there's a second hydrogen. So 6 plus 2 equals 8. Right. But if you look at the hydrogen, it's going to share one of those electrons of oxygen to make its level full, so it'll have 2. 1 plus 1 is 2. Ionic bonding is the other way of bonding. This is when electrons are donated or accepted by another element. And it makes what's called an ion. This is when an atom has lost or gained an electron and then becomes charged. Our best example that we talk about is salt, or NaCl. If you look at the diagram, it has 1 electron, the first picture in the diagram, it has 1 electron in its outer shell. It will then give it up to that second atom to fill its shell so that it has 8. Both are now happy because their outer energy level is full. The first one is going to be a positive ion because it has lost an electron, and the second is going to be a negative ion because it has lost an electron. And now I want you to start thinking about our essential questions. What are atoms? Please think about it, see if you can do it, and answer that question without having to look it up. What are atoms? How are the particles that make up atoms diagrammed? What are the similarities between covalent and ionic bonds? And what are the differences between the two? Some vocabulary that you need to know for this section. An atom, nucleus, proton, neutron, electron, element, isotope, compound, covalent bond, ionic bond, and ion. This concludes Chapter 6, Section 1 of your notes. Please click on Section 2 to continue.